Welcome back to BART Online's Chem 1802. I'm Dr. Kristen Hathcock. This is Dr. Amanda Alaban, and we are back to explore chemical and physical changes. This is our lab for today, and we are going to walk you through the method and procedures and the materials that you need for this lab. Then we will begin going through each activity and give you a highlight of the expectations. So we'll start by providing you an idea of what to expect and what you need. So you'll need weigh boats, a 50 ml graduated cylinder.
Actually, it says 10.
Oh, 10.
50 works.
Okay.
But you also have a 10 graduated cylinder.
You'll need an aluminum weigh dish, tea candle, thermometer. Be very careful with the thermometer. They do break very easily. This is why it comes encased in a plastic container. The nail, forceps. You'll bring out your your scale, electronic balance. In your kit, your Chem 1 kit, you should have some sodium carbonate, 1 molar concentration. You will need to provide either matches or, what do we call these?
A candle lighter.
Candle lighter.
Something that can light a candle.
Okay. An emery board or nail file, something that you can roughen up your nail.
Here's the 10 milliliter graduated cylinder that you should have added. Polyacrylate comes in a brown bag. Test tubes, but I've gone ahead and added them to the test tube holder. This test tube holder was found in this box. So I just had to do some adjusting of the box to get it to stand up. Your medicine cups, your 250 milliliter beaker, and your ruler, and as always, something to write with and a calculator.
Okay.
And make sure you dress appropriately. So fancy apron, your gloves, your goggles, and your hair tied back.
Okay, so we're going to go ahead and explore chemical and physical changes. And of course, then we need our bottled and purified water to remove any solids that we may encounter. Okay.
And food coloring I know is also included in here. As you can see, this is quite the extensive list for this experiment, so you're going to need quite a few chemicals.
Okay. We need the hydrochloric acid solution, 1 molar, comes in the chemical 2 set.
So go through and make sure that you have everything that you need. There's my magnesium ribbon. Okay. Phenolphthalein comes in like an eyedropper bottle and is got a little plastic bag and wrapped in, it does say phenolphthalein on it.
You'll also need copper sulfate solution, 0.5 molar solution.
Okay. Sodium hydroxide is 1 molar and is in a plastic bag and should be, I believe, along with hydrochloric acid. So here's your sodium hydroxide solution.
And finally, our HCl 1 molar solution.
So
when you unpacked your box, when you received it, you would have had an itemized list. If not, it should be available on your course shell. Okay, I believe that we've gone through all of the chemicals that are needed for this experiment, and we will go ahead and go through the experiment. First thing that we should always do is pre-read our labs and obtain all the materials, which we've done. We cleaned and sanitized our work area. Of course, we're working in a lab. You guys will be working in your kitchens or your dining rooms. I suggest with this particular lab that you stick to a kitchen area due to the fact that you'll be working with HCl. Now, HCl is the same acid that's found in the stomach, so it can be an irritant, and you do want to be careful because getting any of these solutions on your skin although a diluted concentration still can irritate the skin.
Same with sodium hydroxide. If you start to feel like your fingers are getting slippery, check your gloves, make sure you don't have any holes in them. But with the concentration that you are dealing with sodium hydroxide, the worst it's going to do is dry out your skin, so you have that chalky feeling that you, and maybe putting some lotion on for a couple days will help cure that.
Okay, so we're going to prepare 2 solutions of colored water, yellow and blue. We're going to use the graduated cylinder to measure out 10 mils of water and add 10 mils of water to each of our 2 small cups. And we'll add 1 to 2 drops of our food coloring. We'll set those aside. Now, we're using room temperature water, and room temperature is usually around 25 degrees Celsius. If it's not quite room temperature, you can let it sit for a moment. Exact temperature doesn't matter.
And I'm having just a little bit of problems weighing, just getting close. So I'm using a pipette just to get, so I don't have to keep pouring back and forth. Makes it a little easier when you get to really close. And like I just did, if you make a mess, which is now a good topic of discussion, wiping these up with paper towels is will be okay.
Chemistry can be fun. It can also be messy.
And that's why with like this particular lab, make sure you want to do it close to the sink. Phenolphthalein, if it's in a base, if you've got it in a base, it will turn pink. So pink colorations, you've probably got some baseline around. Alright. So I've got my yellow food coloring and I've got blue food coloring. And again, it doesn't take a lot, so just maybe 1 drop. There's your wash. Okay. And make sure you get these a good swirl to mix them around. So now we got water in a large cup.
Okay, that's our wash and our activities. Okay. All right, so, all right, place 2 test tubes in our test tube rack. We're going to use 10 mils of our graduated cylinder, and we're going to add 2 mils of our 1 molar hydrochloric acid to one of the test tubes. Okay, so here we go. 2 mils to,
and this one's kind of nice because it's in a little dropper, so it makes it a little easier to control versus pouring out of a bottle.
and again, read at eye level, and you want to read at the meniscus, which is the bottom of what we would call
Bottom of the curvature of your liquid.
Okay, and one of the things that you want to do, oh, you're doing over here, sorry.
Try and keep things separated so that or labeled so that you know what you're working with, because both sodium hydroxide and hydrochloric acid are clear, so you want to make sure that you can distinguish them. So good idea is to label them. That's what we're doing with the pencil.
Okay, so there's my HCl. Okay, and always recap your chemicals.
And again, with this particular lab, be cautious of like cats jumping on tables, or be aware of where your pets are, and also be aware of your children.
Okay, so now I'm going to rinse my cylinder. I'll use my beaker for this. We're going to rinse it 3 times to make sure that we get all of the hydrochloric acid out. Now I'm going to add 2 mils of my sodium carbonate solution. Yeah, there it is. And do the same thing. I'm going to put 2 mils. Okay. Yep. Okay, and I'm going to record the color of the contents of each test tube in my data table. Now your lab comes with a data table. Okay, so we're in activity 1 here, and the initial color of my items. We're also going to test the temperature of each of these items.
And while she's doing that, I'm just rinsing what's going on, rinsing the graduated cylinder so it's ready for the next part of the experiment.
And again, if you have family or friends that want to help you with your lab, it's always great to have a partner. Okay. So the temperature that I have, well, a little chilly in here, is approximately 16 degrees. Okay. Again, excuse me for reaching in front of you there. Again, you always want to rinse your equipment. Okay, so,
And we're going to repeat with sodium carbonate.
okay. So we'll get the temperature of the sodium carbonate, and we've noted the color of our initial (16 degrees) as well. Okay. And we're going to make some observations about our solutions.
Now, clear and colorless are 2 very different terminologies. Clear means that you can see through this, so this yellow solution is clear, but it does have a yellow color. Water is a good example of a colorless solution, so be careful with the 2 terminologies there.
Okay, so these are some observations. Okay, now we're going to combine our HCl test tube 1 with the sodium carbonate solution, which is the Na2CO3. Gently swirl to mix and insert the thermometer. So we're going to look to see any physical or chemical changes by combining these 2 solutions together and see what happens.
Now, I actually want to let you guys observe, see what happens, so I'm trying to give that away.
So we're not going to tell you what actually happens. We're going to see what you guys come up with.
So I'm just mixing now the 2 solutions. So I've mixed them together. I saw what happened and I know what should happen. So sodium bicarbonate and hydrochloric acid, or sodium carbonate and hydrochloric acid are here.
Okay, so what you will do in activity 1 is you will write down what observations that you saw occur. Did you see any temperature? Did you see any temperature changes? Did you see any physical changes? Were there color changes?
You might also test for, you might waft. So take your test tube and waft over. Some of these might give off an odor for a gas. So you might test that.
And then you're going to write here whether it was a physical or it was a chemical change and explain how you know the difference. And again, if you don't remember what the difference is between a physical and chemical change, please go back to the beginning of your pre-lab where there are definitions between the difference in a physical and a chemical change. And you explain why you chose physical versus chemical. Okay, so that was activity 1. We're going to take a look at activity 2. Again, we're going to use 2 test tubes, and we're going to add 10 mils of water to 1 test tube with a graduated cylinder. It's still clean. I promise. I washed it off. And when you're not using your thermometer, you put it back in your plastic case. And while she's doing that, I'm going to weigh out 0.3 grams of sodium polyacrylate. Put that in the test tube.
Okay.
Okay. Okay, I'll turn on my scale. I'll tare it, make sure that I'm in the gram mode. I'll put in my weigh boat. I'll tare it again to take off the weight of my weigh boat. And I'm going to weigh out 0.3 grams.
Now 0.3 is not a lot, so don't get overzealous and try to pour the whole package in. Just takes a little bit.
And if you're at 0.29, stop there. Believe it or not, air friction actually will have an impact on whether or not you're close. Okay, so I've got 0.3 grams. Okay, so record the color of your contents. Again, observations have a lot to do with whether or not you have a physical or chemical change. Record the color of the test tube. Measure the temperature of your water. And don't forget to clean your instruments in between each and every activity. So here's our disposal. So turn them upside down.
And we'll rinse these up with water.
Okay. Okay. Temperature of the water.
And there's a good reason to have like a gallon of distilled or purified water, just because we'll go through a lot of water.
16 degrees for the temperature of our water.
And if you turn these upside down, that'll help with the water draining out so that they don't fit. So you might set these off to the side where you're not going to hit them, and just let them turn upside down so that the water can drip out.
Okay, so to a second test tube, we're going to add the polyacrylate. Okay, and again, observations about our solids, honors. We're going to take the 10 mils of water and we're going to add it to our polyacrylate.
Okay. But I don't want you to see what happens because I don't want to give the fun away for this. Exothermic or endothermic here? What's that? Do you talk about exothermic or endothermic?
Mm-hmm.
Okay. So what you might also feel the test tube. Is it giving off heat or is it releasing heat? So is the test tube getting cold or is it getting hot?
Okay, and so in activity 2, we went from a white powder, added the water, what is the color of your final item. We're going to measure the temperature again. And we're going to let you do that because that's half the fun. What observations? As Dr. Alaban stated, was it cold? Was it hot? Again, note, is it a physical or a chemical change? How do you know? Okay, so that was activity 2. Okay. All right, we're going to move on to activity 3. We're going to use the last 2 test tubes. We're going to take 2 mils of our 0.5 molar copper chloride, copper sulfate solution, my apologies. 2 mils. Okay. 2 mils.
And with the small volumes, the 10 milliliter graduated cylinder is actually easier to use.
Now, can anybody tell us what gives us the blue color to our solution?
I know, but I'm not going to tell you.
Okay, we'll go ahead and put that into one of our test tubes. And while she's rinsing that, I will note that this is our copper. Okay. And then we need 2 mils of our 1 molar sodium carbonate. Okay. Again, we're going to take the temperature of both of our solutions. Degrees. Okay, we'll record.
There might just be a good idea to have some paper towels.
You're hilarious.
I am not known for being a clean chemist. I've made numerous messes and had numerous mistakes.
Again, it's about the mistakes that are fun.
Yeah.
So
just be careful not to do anything that you shouldn't do.
All right, so we'll record any observations.
And these are snugly fit into that box.
So, some observations. Copper is blue. And if you want to make some great observations, it's always good to put a white paper behind your test tubes. Gives you a better.
Yeah. I keep seeing the reflection of the blue for that clear.
Okay.
Or for the colorless solution.
Okay, so if I separate, okay, notice my sodium is clear and colorless, the copper is blue.
So a lot of times be careful of how you're looking at a solution.
Okay, so now we're going to combine the contents of the 2 test tubes, okay? And again, because we don't want you to see what actually happens, we want you to observe again.
Ooh, it's really cool.
All right.
Even for seasoned professionals, it's still fun.
These are fun. Okay. Again, you want to notate any observations, any heat given off, or is it cold?
So is it exothermic or endothermic?
Okay. On top of that, did we have any color changes? Did you have anything that was created, meaning any blobs? There's a specific name for those blobs. Okay. All right, so that's the end of activity 3. And once again, with the activities,
Be careful, handoff.
handoff. All right, please note any observations and specific observations. And if actually nothing happens, there's always a chemical reaction. So never, ever put nothing happened. There's always a chemical reaction.
Now, I did note on one of the steps that some of these test tubes you may not be able to get rid of the product, so some of the test tubes you may just have to throw into the trash.
And that's okay. You're working with very dilute amounts of materials, and although some of them are heavy metals, we are aware that you will be disposing of them. So that's the end of activity 3. Okay, so now we're going to be working with activity 4. Go ahead and stop it.